Hey everyone, welcome to Professor Long's Lectures in Anatomy and Physiology. I'm Professor Bob Long. You guys either stumbled across this video on the internet and you're not in my class, or you are in my class and you were directed to these videos to learn this material. We're in the COVID-19 shutdown, so everything's being done through YouTube. If you're not in my class, learn the structures and the things that your teachers want you to know for your class. I'm teaching it the way that I want my students to learn, the things that I want them to pay attention to and focus on. So I may not cover everything exactly the way that you need it, but learn it the way that your instructor wants. If you're in my class, know this. All right, so today's lab is going to be over the parts of the microscope, or the anatomy of a microscope. I think it's important for students to learn this. Now, because we're in the coronavirus shutdown, we can't have face-to-face labs. So what we're doing is I'm going to go over the parts of the microscope, because when you guys do get to part 2, A and P, you may have to use the microscope, but you should at least know what the parts are when we tell you grab this, twist this, turn that. You need to know which parts you're grabbing. So the anatomy of the microscope, or the parts of the microscope, will be on your first lab test. So make sure that you know them. We can point to one of these parts, like this little silver thing here, and say, please ID the structure or ID the microscope part, and you should know the name. I may not cover all of the names that are on the list of things to know, but I'm going to go over the ones that are important. Now, some basics are, obviously the bottom of the microscope is the base. This would be called the body of the microscope, and then this part is sometimes referred to as the head of the microscope. I'm not going to ask you for the base, the body, or the head, okay? And some people refer to this part as the arm or the neck of the scope, depending on who you have, and I'm not going to do that. Here's the parts that are important for you to know. These two structures right here, and I'm going to turn the scope in different directions for you, but there's two of these. Our scopes are called binocular scopes, because bi meaning two and ocular meaning eyes. You can look with both eyes. Some scopes only have a single ocular, and they're called monocular, and you have to close one eye to look through them. Now, these two structures are called oculars, or they're called an eyepiece. If we were to ask for this part on a lab test, you can say ocular or you could say eyepiece, and both would be correct. Now, when we look at the ocular or the eyepiece, don't ever take one out of a scope. I did, but you shouldn't do that. But if I look at them, they have some numbers on them, and one of those numbers says 10x, the other number says 20, and the 10x tells you how many times this little piece of glass will magnify something. So if I could simply look through this and look at my hand, it will appear 10 times larger than it really is. The other number tells you the field size, the size of how big of the area that you can see. We're not concerned with that. So these are the oculars. Now, down below this part, there's a little rubber wheel here that has all these silver or metal looking structures hanging off of it. This is called a revolving nose piece. Revolving because it revolves or rotates. So some people call it a rotating nose piece, but we have oculars, we have the revolving nose piece, okay? Now the revolving nose piece revolves because it allows us to change which one of these metal objects is pointing down at our stage. So this flat black structure is called a stage or a mechanical stage. It's called mechanical because it moves. Some old school microscopes don't have a mechanical stage. It's a fixed stage. We don't have that. So ocular, revolving nose piece, mechanical stage. Now, these structures that are on the revolving nose piece are called objectives. The objectives, there are 3 of them usually on our microscopes, at least the ones that we use, although they do have a slot for a 4th objective, we don't use it. These objectives, if you notice, one has a red line, one has a yellow line, and the other has a blue line, and if you look at them, each one is progressively longer. And if you look at them closely, there are some numbers on the side. The red objective, the smallest one, has a 4x. What it means is the piece of glass in there, called an objective lens, has the ability to magnify objects to appear 4 times larger. Whatever's sitting on this stage will look 4 times bigger. And as it goes through here, it goes off a mirror, and then it will be magnified another 10 times. So if this makes it 4 times bigger, and this makes that 10 times bigger, the smallest you will see something, if you look through this microscope, the lowest magnification is going to be 40 times larger. That would be like looking at a 6-foot person who appears 240 feet tall. Anyway, Sorry if there's some background rumbling. There's a lot of rain right outside this window. We're in South Texas. We're getting a lot of rain, thank goodness, because it's hot outside and my yard is soaking up all the water. Anyway, so now, right now, there's only 4 parts that you need to know. Identify the part, ocular. Identify the dark structure, that would be the revolving nose piece. Identify the silver tubes, those are objectives. Now, if we got specific, this would be the low magnification objective, the red one. The yellow one is called the middle magnification or the middle power objective. If you look at it, it has a 10x on it. 10x times 10x is 100x. And then the last one, the blue one, is our high power or high magnification objective. It has a 40x on it, and times another 10 would be 400 times larger. So it will make objects look 400 times bigger than they really are. And that's the way that we're going to increase our magnification if we need to look at detail under the microscope. So when I have a slide on here, if I have the low power objective and I'm focusing, it's going to look 4 times larger than it really is. I'm sorry, 40 times larger than it really is. Now, sometimes that's good enough. Students always want to go to the highest power objective, and you don't always need to do that. You need to look at all 3 magnifications and decide what is the best magnification for whatever slide you're looking at, okay? And when you do turn the revolving nose piece, don't grab the objectives and turn them. They actually unscrew and screw in, and if you unscrew one, it's a little too far off. And the microscope is set up that when I go from one to the other, they should be pretty close in focusing. But if they're unscrewed, they will not focus properly. So please don't ever grab the objectives. That's why we have the revolving nose piece. So, oculars or eyepiece, revolving nose piece, low magnification, middle magnification, and high magnification objective, or in general, they're called objectives. The mechanical stage. Now, if you look down on our mechanical stage, there's a little metal clip here, and that's where we put our slides. If you were going to mount a slide, the first thing you do is you open up this little clip. You put the slide in this very back corner here where it's L-shaped, and then you very gently set the edge of the stage clip on the edge of the slide. They are spring-loaded, but don't let them go because they'll snap and chip slides. So now, when you are asked to mount a slide, you have to have the red objective, the low magnification objective in place, and your stage should be all the way down. You should have maximum working space here. You put your slide on, you put it back in this little corner securely with the label up, and then you set it on here. Now the reason this stage clip, and you need to know this metal part, is called the stage clip. I want you to know it as the stage clip. That stage clip is going to hold your slide so that when I move these knobs, you can see the stage moves, and if I look down on here, I can see that the stage clip moves side to side. That's how we're going to find the object. When you look through the oculars, they are lined up with mirrors with this objective. It's like you're looking through a tube. If what you want to magnify or see is outside that tube, you can turn microscope knobs for days and never find what you're supposed to see. As a matter of fact, that's what happened when I was in high school. Our teacher said, there's some instructions, there's a microscope, there's some slides, figure it out. We all looked through here, turned knobs for days, didn't know what we were doing, got mad. We looked at the picture in the book and we drew that and pretended we saw it. And I know some of y'all have done that. No more. You're going to learn to use the microscope the correct way. So, when I ask you to mount a slide, you're going to mount it using the stage clip. Now, on the side of the mechanical stage, there's a metal stick here that has 2 rubber knobs. The bottom knob moves the stage or the stage clip laterally in the y-axis, and this would be moving it front and back, or this way in what we would call the x-axis. So some people call this the x-axis and the y-axis control knobs. I don't care if you know which one's which, you'll figure it out. So if I ask you for these knobs, these structures right here, they're called the stage control knobs. That's the term I want you to use. The stage control knobs control the movement of the stage. So the first thing you do when you mount a slide is you don't even look through the microscope. You look from the side here and you make sure that your slide is centered. What does that mean? Well, I'm going to raise this stage up for a second. and show you a couple of things underneath here. This black tube sticking up from the base is called the lamp or the light source. Okay. In order to see things, we have to shine photons of light on it. The photons bounce off the object, hit your eyeball, and trigger a visual response. The things we're looking at are so tiny that most of the light from this room would miss them. It would be like me shooting a shotgun, and across the room there's a single piece of thread hanging from the ceiling. If I'm 30 yards away, what's the likelihood any of the BBs from the shotgun are going to hit the thread? Pretty low. The BBs of the shotgun are similar. They represent the concept of the photons, and the thread is what we're trying to look at. Now, what if I took a big metal funnel so that all the BBs hit the funnel and were funneled to that thread through a little tiny hole? What's the likelihood a bunch of BBs are going to hit it now? Way high. So when we shine light out of this light source, it's going to go out in an infinite number of directions. So right above it is this little black cylinder looking thing that has these two little metal pieces sticking off, and that is called a condenser. And although I probably shouldn't do this, I don't want to loosen it, but we have one of our scopes where the condenser pops off. And if you look from the top of the stage, there's a big hole in the stage that has this little lens in it. That's the condenser lens. Just know it all as the condenser. But the point of the scope is when I mount a slide and I turn it on with the power switch and I turn the light up, I'm going to center the slide. Now, our slides will have a little object to see and a little cover slip that's either round or square. Whatever's underneath that cover slip is what you want to see. When I mount my slide, if this condenser lens, which is lined up with all of these structures, if that condenser lens is not sitting where that little patch of glass is, the cover slip is on your slide, if they're not lined up, you can turn the knob for days and you'll never see what you're supposed to see. You need the cover slip of your slide sitting right over that condenser lens in the beam of light coming out of it. So, the first thing you do when you get a microscope is actually you're going to plug it in. You're going to use the power switch, the on-off switch, to turn it on. And then there's a light control knob or a light intensity control knob. And it's essentially a dimmer switch like you have on a light at home. And you want to turn the light up some. Now, most students turn it all the way up. They look through here and they get blinded. So you turn it up about halfway. If you need more light, you can add it. If you need less light, you can turn it down. So turn it up about halfway. Plug it in, turn it on, turn the light up to about 4. Then you're going to mount your slide, and then looking from this angle, you're going to center your slide by turning the stage control knobs so that the cover slip on your slide is sitting over this condenser lens. Now I know what I want to see is in the tube that I'm looking through. Problem is, it's so far away we would never see it. So then, the next step would be to raise our stage. Now, I know I've lost some of the continuity of what I was trying to get across, which are just the parts of the microscope, but I want you to understand how the microscope is used. So let me review the parts. I'm going to do the last couple of pieces, and then we'll finish up with the scope. These are oculars or eyepiece. Revolving nose piece, the black wheel. Objectives. Red is low magnification, yellow is middle magnification, blue is high magnification. The mechanical stage with the stage clip. We have the stage control knobs, we have the light source, and we have a condenser. Okay, you need to know those parts. Ocular or ocular or eyepiece, revolving nose piece, objectives, low, middle, high, mechanical stage, the stage clip, the condenser, and the light source, and the stage control knobs. Okay, now over here I have the on-off switch or power switch, my light control switch, and then these two knobs are stacked on top of each other. The larger of the two knobs, if I wiggle it and you stare at the stage, you see that the stage moves. Now, if I grab the smaller knob and I turn it, you see that the stage does not appear to move. It's moving, but it's moving very fine increments, where this one is making very large movements. So we call this the coarse focusing knob and the fine focusing knob. The larger of the two is the coarse focus or rough focus knob and the fine focus knob. So if I asked you guys to read my fingerprints from where you're at, you can't see them. So what you might say is, hey, Mr. Long, move your hand closer so I can see your fingerprints. And if I started to move like this, about 1 millimeter every 5 minutes, we would be here all day before you see my fingerprints. And one of the mistakes that students make is they use the fine focus knob first. Don't. You start with the coarse focusing knob or the bigger of the two knobs. I always remember big, red. You start with the big knob and the red objective always. You end with the big knob and the red objective. Coarse focusing, low magnification. So when you get a slide out, your stage should be all the way down, and you can check that with the coarse focusing knob. I have a lot of clearance here. I mount the slide, I center the slide, and then the next thing I'm going to do with the red objective in place is raise the slide all the way up. That would be like you saying, okay, Mr. Long, put your fingers at the end of my nose, and now there's only one direction I can go. And I start backing off using the coarse focusing knob until I see it. You don't just stop when you see it, you go until it gets really sharp, and then it gets blurry again, and then you go back and forth and get it as good as you can get it with that knob. Then you make very fine adjustments with the fine focusing knob. If you need to, you can move the slide around a little bit to see things, and like, oh, I want to put my pointer, there's a pointer in here. Look at whatever you want to see in detail. If you need to go up in magnification, then you go to the next highest magnification. Once you switch objectives, they should all be very close in focus. You should only use the fine focusing knob to make very fine adjustments and wiggle it, maybe turn the light up. You're always going to be turning knobs and moving things, and you make your observations. If you need to go to the high magnification, you do so. You adjust your light a little bit, you move your slide in fine focus, and you make your observations, do your drawings, whatever you need to do a lab report. When you are done, you always go back to the red objective, lower the stage with the coarse focusing knob, and then you take the slide off and you're back where you started. Okay? That's sort of a how to use the microscope and what are the parts of the microscope together. Now, we're not going to get to use the microscope together because we're in this shutdown, but I'm going to review the parts for you one last time. This is what you need to know for the lab test. And if you're in my class, you can use the terminology that I use, even though it's written a little differently on the list of things to know. You need to know the ocular or eyepiece. You need to know the revolving nose piece. You need to know the objectives. You need to know the stage or mechanical stage. You need to know the stage clip, the metal part, and you need to know the condenser. You can either point to it underneath here or the lens on top. And then you need to know the light source or lamp, and you need to know the stage control knobs. Over here on the body, you need to know the on-off switch, the light intensity control knob or the light control knob. You need to know the coarse focusing knob and the fine focusing knob. Okay? Those are the parts I want you to know for the lab test. Everything else is just a little extra. So you will see pictures of the microscope with pointers saying, please identify the round rubber wheel, please identify the small wheel, please identify the structure, please identify this microscope part, please identify that microscope part, and you should know all the parts. I hope you learned something. I hope you had as much fun as I did. Sorry I rambled a little in there, but hey, these are all one-take videos. Do this till you can't stand it. Do it till you can teach everyone all the parts of a microscope, and then do it 5 more times. Again, you got to want this stuff, and you have to be putting in a lot of time perfecting it to where you could look at a microscope without any list available and go ocular, revolving nose piece, objectives, stage clip, stage control knobs, lamp, condenser, on-off switch, light control knob, coarse focus, fine focus. If you can't do that, you have some work to do and you have some practice you need to put in. Thanks for watching. I hope you had as much fun as I did. See you in the next video.